Okay, Assalamualaikum. So now we are going to continue for our problem solving questions. So let's try doing example 16 from the textbook. Okay, so let's read the question first. The speed time graph shows the motion of a car for a period of 14 seconds. Calculate the average speed for the first 6 seconds and then find the value of t if the distance travelled by the car for the first 4 seconds is half the distance travelled at a uniform speed, and the last one the value of v if the acceleration for the last 2 seconds is 3.5 meter per second. Okay, so let's try doing question A first. Okay, average speed. The formula for average speed equals to the total distance over time taken. The total distance is the area under the graph. So for the first 6 seconds we have two shapes there, a trapezium and a rectangle. So for the trapezium, 1/2 times 5 plus 10 times 4, and for the rectangle is 6 minus 4 times 10. Divide by the time taken, 6 seconds. Okay, then here to 15:30 plus 20 distance meter over 6 seconds, so 50 over 6 meter per second. So 50 over 6 equals to 25 over 3. Okay, simplify. Okay, so next the value of t, distance travelled by the car for the first 4 seconds. So the first 4 seconds is the first trapezium, the smaller trapezium. It was 30 just now. Okay, let's go back here. Distance for the first 4 seconds. For the first 4 seconds equals to half of the distance travelled at a uniform speed. Uniform speed, you can see the 10, so half of the t minus 4 times 10. Okay, so 30 here, 1/2 times t minus 4 times 10, 5 5t minus 20, 30 plus 20, 50, 5t, t 50 divided by 5 equals to 10. So the t is 10. The value of v, question C. The value of v if the acceleration for the last 2 seconds is 3.5. Okay, acceleration meaning is the gradient. Acceleration for our speed time graph refers to the gradient, and then the gradient for the last 2 seconds is 3.5. Okay, gradient for the last 2 seconds is actually the same as the gradient for the last 4 seconds. Okay, they are on the same straight line, so the gradient for the last 2 seconds and last 4 seconds, acceleration just now was 3.5. Then we use the formula for gradient, v minus 10, 14 minus t just now, 10. Okay, v minus 10 equals to 3.5 times 4, 7 to 14, v minus 10. Okay, so v is 24. Okay, so we are done with example 16. So shall we proceed with another example? Example 18. Okay, example 18 here. Calculate the rate of change of speed for the first 3 seconds is the gradient class. Okay, so the gradient 30 minus 12 divided by 3 minus 0 is 18 over 3 equals to 6. Okay. B, distance in meters traveled for the first 10 seconds. For the first 10 seconds, meaning we have two shapes here, the trapezium and the rectangle. So distance equals to 1 over 2 times 12 plus 30 times 3 plus 7 minus 30. 7 times 30, sorry. 42. No. 42 become 21. 63 plus 210 equals to 273. So the distance is 273 meters. Okay, so the last question, example 18. The value of t if the magnitude of the rate of change of speed after 10 seconds the same as the magnitude for the first 3 seconds. Okay, so the magnitude meaning the number is the same regardless of the direction. We can see that the one is going up and another one is going down, meaning one is positive, another one is negative. Okay, so acceleration after 10 seconds. Acceleration after 10 seconds equal to acceleration for the first 3 seconds. Okay, so for the first 3 seconds just now we had 6, so we'll use negative 6 here. Negative 6 after 10 seconds is 0 minus 30 divided by t minus 10. Okay, so negative 6 t minus 10, 20, negative 60 plus 60, negative 30, so negative 90, negative 60, t equals to 15. So the value of t is 15. Okay, so that's all. So we are done with the problem solving. Okay, do lots of exercises. So your homework is self practice 7.2D, question 2 and 3. Okay, let me write down here. 7.2D homework question 2, 3. Okay. See you. Bye bye.